Do you understand this? Here's a basic input and output. When this is off, it is 0 in binary. However, when this is on, it is 1 in binary. That's the standard representation. Here we have an AND gate circuit. It does not output anything when inputs are off. It requires both inputs to be turned on, which is 1, to make the output 1. That is the most simple gate in this game. Here's a chart to show how it works. Here we have an OR gate circuit. It does not output anything when inputs are off. It requires only one input to be turned on, which is 1, to make the output 1. Both inputs can be 1. Here's a chart to show how it works. Here we have an XOR gate circuit. It requires both inputs to be different. If one is 1, the other must be 0. Both must not have the same value. Here's a chart to show how it works. Note that you can use XOR to reverse the value of the input, which is what NOT does, using a constant. Moving on to advanced subjects. Here we have memory. When the input and set have a value of 1, the output will always be 1 until we hit the reset. In gated SR latches, the input is E, or as it is shown, gate. Here's a gated SR latch. It uses 2 NOR gates and an AND gate. Because this game doesn't have NOR or NOT gates, we needed to make them ourselves. Pretend the OR and the NOT gate above it is combined. Note that Q represents high and Q bar represents low. It is a little bit complicated, so just see Q as 1 and Q bar as 0. The gated SR latch works exactly like the memory block, which in both they store a single bit, which is 1 or 0, and can easily work without the AND gate. Here's the chart and circuit. And finally, we have the last gate in this game, the IF gate. This is not a real binary gate and is used to check for conditions, especially if the person who inputted was an admin or was a part of a team. We can use this for many things. Moving on to mathematical binary, here position matters. This is 1, 2, 4, 8, 16, 32, 64, 128. Wait, there's a pattern. It keeps doubling. We can represent values by using zeros and ones. For example, 1, 1 is equal to 3, as 1, 0 equals 2, and 0, 1 equals 1. It is pretty hard to explain, so I will just show you how we add. Here is 1 in mathematical binary. What is 1 plus 1? Easy, 2. So we turn off the 1 and turn on the 2. Here we have 1, 0. What is 2 plus 1? Also easy, 3. So we turn off the... Wait, it's not 4. It can't be 1, 0, 0. So just turn on the 1. Here we have 1, 1. What is 3 plus 1? Now we can use that. Turn off the 2 and 1 and turn on the 4. It's 1, 0, 0. Here is 5, 6, 7, 8. Wait, did you notice something? 2 ones make up a different output than the output 1, 1 makes. There's an AND and XOR, so can't we just do... Well done! You just made a half adder? The backbone of my calculator. We won't delve too much into binary maths and all those tricky subjects, but you can search them up. I hope this gave a good introduction to binary and also binary within this game, and I'll see you on the next video. Peace.